Guys, so I have another example here which we are going to solve using separation of variables. So just like we did in the previous example, we are going to use the same method here. But this example looks a little bit complicated from the previous one. So let's look at how you are going to do this. So the first thing you would like to do here is to separate the differential coefficient dy dx from the other terms in this differential equation. Okay, so let's look at how we are going to do this. So I will focus on the right hand side where we have 2 common to y and then dy dx. Okay, so I'm going to distribute 2 to both terms in the bracket, and then from there we continue. We are going to have x, we're going to have x dy dx minus 3 to be equal to 2y plus 2 dy dx. Okay, so we've expanded the bracket. Okay, so the next thing I'll do is that I would take the term with the dy dx attached to it on the right hand side to the left hand side. Okay, so you are going to have x dy dx minus 2 dy dx, okay, to be equal to 2y plus 3. This is what you are going to have. Okay, so from here what I'll do is that you see that the dy dx is common to these two terms on the left hand side. So I'm going to factor it out. Okay, so you're going to have x minus 2 dy dx, okay, to be equal to 2y plus 3. Okay, so from here what I will do is that I would like to separate the differential coefficient dy dx, okay, so that I will separate the dx from the dy, okay, so that we can get all the x terms on one side and then the y terms on the other side. So let's look at how you are going to do this. So I'm going to have x minus 2 dy equals 2y plus 3 dx. Okay, this is what you are going to have. But you see that the x terms and then the y terms have not been grouped well. Okay, so we will have to group this. So let's look at how you are going to do this. So to do this, first of all, I will divide both sides by 2y plus 3, 2y plus 3, okay, so that I can cancel out this term here. So at the end, you are going to have x minus 2 divided by 2y plus 3 dy, okay, equals dx. This is what you are going to have. Let me write this here, dx. Okay, so what I'll do is that I will multiply both sides by 1 over x minus 2. I'm going to have 1 over x minus 2 here, okay, so that this can cancel out this. So then you are going to have 1 over 2y plus 3 dy plus 3 dy equals 1 over x minus 2 dx. So this is what you have. So now we are done with the separation of the variables. So now we can integrate to get our general solution. Let's look at how we are going to do this. So I will integrate both terms on the left and right hand side. Okay, when I integrate a term on the left hand side, we are going to get ln of 2y plus 3 divided by 2. And then on the right hand side, I'm going to get ln of x minus 2 and then I'll bring the constant of integration. So this is what you are going to have. So I will rewrite this as 1 over 2 ln of 2y plus 3 equals ln of x minus 2 plus c. So for us to be able to simplify this further, I will represent the constant c with another constant ln of k. Okay, so you are going to have 1 over 2 ln of 2y ln of 2y plus 3 equals ln of x minus 2 plus ln of k. This is what you are going to have. Okay, so now let's look at what you are going to do next. Okay, so I'm going to use a log property, okay, which says that if you have a log b, okay, if you have a log b, you can write it as log of b to the power a. So I'm going to apply this property to the left hand side, okay. So I'm going to have ln of 2y plus 3 to the power 1 over 2, okay. And then on the right hand side too, we are going to use another property where if you have log a plus log b, okay, we can get it to be equal to log of a multiplying b, okay. So we're going to do the same thing there. So we're going to have ln of k multiplying x minus 2, okay. This is what you're going to have. Okay, so from here you can see that the natural log function will cancel out. So at the end you are going to have 2y plus 3 to the power half equals k multiplying x minus 2. This is what you are going to have. Okay, so from here I want to make y the subject, okay. What I'll do is that I will square both sides so that I can take out the half on the left hand side. So I'm going to square both sides. So then we are going to have these two cancelling out these two. So we are going to have 2y plus 3 to be equal to k squared multiplying x minus 2 squared. So let's see what you are going to do next. So I'll take this 3 to the right hand side. Okay, so we are going to have 2y equals k squared multiplying x minus 2 squared minus 3. And since we want to make y the subject, we'll have to divide both sides by 2. So this will cancel out this. And then we are going to have y equals k squared over 2 multiplying x minus 2 squared minus 3 over 2. So this will be the general solution to this differential equation if you use the method of separation of variables. Thank you very much for watching this video. Please make sure you like the video and subscribe to the channel.